Breast cancer is the most commonly diagnosed type of cancer among women worldwide. Some of the most aggressive breast cancers are driven by a transmembrane receptor protein known as ERB2 or HER2, a member of the human epidermal growth factor, or HER family of receptor tyrosine kinases, that also includes HER1, HER3, and HER4. Typically, a healthy breast cell has roughly 20,000 HER2 receptors that are expressed on its surface and confer normal signaling for cells to function as needed. For most of the HER family receptors, signaling begins with the binding of specific ligands, which promotes homodimerization and heterodimerization of receptors on the cell surface. The HER2 receptor does not bind to a specific ligand, but instead remains in a conformation that resembles a ligand-activated receptor, so it is constantly poised for interaction. As a result, HER2 is an ideal receptor for dimerization with other members of the HER family. Dimerization activates numerous downstream pathways that regulate cell differentiation, migration, proliferation, and survival. In particular, the HER2-HER3 pairing produces the strongest mitogenic signaling and may activate two important pathways: RAS-MAPK, which is involved in cell proliferation, PI3K-AKT, which controls cell survival. In approximately 20 to 25% of primary breast cancers, the HER2 protein is overexpressed, resulting in tumor cells with as much as a 100-fold increase or 2 million receptors present on the surface of each cell. These cancers are called HER2 positive. HER2 overexpression leads to a tremendous increase in receptor-mediated intracellular signaling directing the cell to proliferate uncontrollably. For this reason, HER2-amplified disease results in an aggressive form of breast cancer which can progress rapidly. Herceptin, trastuzumab, is a monoclonal antibody specifically designed to target HER2 by selectively binding to the extracellular domain of the HER2 receptor. Preclinical studies show that Herceptin inhibits the proliferation of human tumor cells that overexpress HER2 through multiple mechanisms of action. It is believed to block downstream signaling pathways, flag the tumor cell for destruction by the body's immune system, known as antibody-dependent cellular cytotoxicity, or ADCC, and prevent HER2 shedding. Herceptin may work to enhance the effects of chemotherapy, as shown in multiple preclinical studies. In vitro studies suggest that Herceptin bound to HER2 receptors undergoes internalization, a process known as endocytosis. Once internalized, these receptors may be recycled to the cell surface, maintaining the high surface distribution of HER2 and allowing Herceptin to disrupt downstream signaling while flagging the tumor cell for death. Through several potential mechanisms of action, Herceptin is shown to deliver a multimodal attack against cells overexpressing HER2, a receptor linked to one of the most aggressive types of breast cancer.